The moon is not a sanctuary. It is a target. We often forget that space is violent because our atmosphere protects us. But the moon has no shield. It is naked against the void. On December 12, 2025, we got a brutal reminder of this fact. A robotic telescope in Ireland was scanning the shadows near the Langrenus crater. It was a routine night, quiet, still, boring, until the darkness exploded. A sudden, blinding flash of white light tore through the gray dust. We caught a lunar impact live. And I have to be honest with you, the footage isn't just impressive, it is deeply unsettling. Because what you are watching is not an accident. It is the physics of a bullet hitting a wall. We were passing through the debris field of 3200 Phaethon, a rock comet that is shattering in the deep dark. And that flash, that was a warning shot. As we prepare to send humans back to the lunar surface, we need to admit a terrifying truth. We are not stepping into a new home. We are stepping directly into a cosmic firing range. To understand why that flash near the Langrenus crater keeps astronomers up at night, you have to look past the light. You have to focus on the math. I know, usually math is cold. It's abstract. But in the void, the math is the only thing that is real. And the math of the moon is terrifying. On Earth, we are used to things having weight. If you throw a pebble at a wall, it bounces. If you drop a marble, it rolls. But in the vacuum of space, weight is a lie. The only thing that matters is velocity. The object that hit the moon on December 12th was moving at 35 kilometers per second. Let's put that number in perspective. A bullet fired from a high-powered military rifle travels at maybe 1 kilometer per second. This piece of space debris was moving 35 times faster. At those speeds, the physics of the world we know simply stops working. Solids stop acting like solids. They act like fluids. They act like energy. When that rock hit the lunar surface, it didn't just crash. It didn't thud. It underwent a process called impact vaporization. Imagine the kinetic energy of a speeding car concentrated into something the size of a grape, and then you slam it into a solid wall. That energy has to go somewhere, and it has to go there instantly. It happens so fast that the rock doesn't even have time to break apart. The molecular bonds are ripped open. The rock instantly converts into heat and light. What gets me is that there is no fire. We see a flash, and our brains think explosion, but there is no oxygen on the moon to feed a flame. There is no burning. Instead, what we are seeing is a burst of superheated plasma. For a millionth of a second, the point of impact becomes a miniature sun, a pocket of gas so hot, so energetic, that it glows with a blinding intensity that can be seen by a telescope 250,000 miles away. And it all happens in total crushing silence. No shock wave through the air. No deafening boom. Just a sudden, violent transformation of matter into light. Sometimes I think we underestimate how quiet the universe can be, even when it is being violent. On Earth, our atmosphere is a shield. It catches these tiny bullets. It compresses the air in front of them until they burn up miles above our heads. They turn into shooting stars. They become harmless streaks of light we make wishes upon. But the moon? The moon has no skin. Every grain of sand, every stray pebble, every microscopic shard of dust in the drift has a direct line to the surface. It is a reminder that out there in the darkness, even the smallest thing can become a weapon if it is moving fast enough. But as unsettling as the physics are, there is another layer to this story. Most lunar impacts are random. Stray rocks that have been wandering the solar system for millions of years, bumping into things by chance. But this one was different. It didn't feel like a random accident. It felt like part of a pattern. When researchers started looking at the trajectory, when they traced the path of that bullet backwards into the dark, the story went from a simple physics lesson to something much more haunting. Because this wasn't just any rock. It was a piece of a ghost. Where did this thing come from? That is the question that turns a scientific observation into a cosmic mystery. When astronomers traced the trajectory of the flash, they realized it wasn't a lonely traveler. It was a fragment of the Geminids. We see the Geminids on Earth every December as a beautiful meteor shower. But on the moon, they are not a shower. They are a bombardment. And unlike most meteor showers that come from icy comets, those dirty snowballs of the outer solar system, these come from an object called 3200 Phaethon. Phaethon is what scientists call a rock comet. And I'll be honest, it is a freak of nature. It is a 5-kilometer wide chunk of rock that follows a brutal orbit. It dives closer to the Sun than almost any other named asteroid. At its closest point, it reaches temperatures hot enough to melt aluminum. It gets baked. It gets tortured. I can't shake the feeling that Phaethon is a victim of its own path. As it plunges into that solar furnace, its surface doesn't just melt. It shatters. It cracks and explodes under the thermal stress. It is literally screaming into the void, shedding its skin, leaving a trail of ghostly debris drifting through space. The flash we saw on December 12th was the moon driving through the shrapnel of this crumbling giant. What gets me is the scale of time involved. This grain of sand had been circling the sun for eons. It survived the heat of 1,000 orbits. It drifted in the silence for millions of years, only to vanish in a millisecond against the lunar gray. Some researchers wonder if Phaethon is a dead comet, a skeleton of ice that has lost its soul. Others push back, arguing it is just a strange asteroid coming apart due to the sun's intensity. I don't know which idea is right, but it is hard not to wonder what else is hiding in that debris stream. Here is the unsettling part. If we are seeing these impacts live now, it suggests the debris field might be much denser than our models predicted. If the moon is currently standing in a cosmic firing range, we have to ask a question that most people are avoiding. What happens to the people we are about to send up there? Here is the part that really keeps me up at night. Right now, we are in the middle of a new space race. We aren't just looking at the moon through telescopes anymore. We are planning to move back. NASA's Artemis missions, the habitats planned by China and Russia. These aren't just about planting a flag and leaving a footprint. We want to build. We want to stay. But when you see a live impact, like the one near Langrenus, you start to look at those blueprints through a different lens. On Earth, when we build a house, we worry about the weather. Rain, wind, snow, maybe the occasional storm. But on the moon, the weather is a constant, invisible rain of micrometeoroids, bullets that you never see coming until it is too late. I'll be honest, I think we underestimate how hostile the silence of the void can be. We talk about the moon as the 8th continent, but continents on Earth have a thick, protective blanket of air. The moon is a world without a shield. Every marble-sized rock we have talked about is a potential habitat killer. Some researchers argue that the risk is manageable. They say the moon is vast. They say our bases will be small targets. But others push back. And this is the part that messes with my head. It is not just about a direct hit. In the moon's low gravity, when an object slams into the ground at 35 kilometers per second, it creates a secondary impact. It throws up a curtain of jagged lunar dust and rock shards called ejecta. And because there is no air to slow them down, these shards can travel for miles. They move like supersonic shrapnel across the horizon. Think about that. You could be 10 miles away from the impact site. You wouldn't hear it, but seconds later, your habitat could be shredded by a horizontal wave of razor-sharp rocks moving faster than a rifle bullet. You could be in the line of fire without ever seeing the flash. What gets me is the psychological toll of that reality. Imagine living in a lunar habitat, sleeping in a bunk, eating your dinner, knowing that at any millisecond, without a single sound of warning, a stray piece of 3200 Phaethon could punch through your roof. It makes our dreams of colonization feel incredibly fragile. Are we really ready to live in a place where the darkness is constantly throwing bullets at us? Or are we just arrogant enough to think we can conquer the drift? I don't know if we have truly reckoned with the violence of the lunar frontier. Every flash we record is a data point for our survival, but it is also a reminder that the universe doesn't care about our missions. It doesn't care about our timelines. It just keeps moving. We are moving into a neighborhood that has been under heavy bombardment for 4 billion years, and it isn't going to stop just because we have arrived. It is a chilling thought, but maybe that is the price of becoming a multi-planetary species. We have to learn to live in the crosshairs of the void. We have to learn to build shields where nature didn't provide them. In the end, that flash near Langrenus is just one tiny event in an indifferent universe. The moon has been taking hits like this since the dawn of the solar system, and it will keep taking them long after we are gone. But for those few frames in December, we were connected to that violence. We saw the void reach out and touch something real. We often underestimate the silence of space, but the moon isn't just a dead rock. It is a scarred witness, a bodyguard that has spent eons protecting Earth from the very same drift that caused this impact. The darkness is finally starting to reveal its secrets. We are left with an unsettling glimpse of light in the eternal night, a beautiful, terrifying reminder of the firing range we call home. In cosmos we trust,